All right, so this is kind of an add-on video to what I've already kind of explained in the video previous to this, but I wanted to kind of add these things for the online quiz that I'm going to give you. So let's say I'm doing number 17 and 18, and I modified the worksheet a little bit because you'll notice that I'm not given all three sides of the triangle, okay? So if I'm trying to find the sine of z for number 17, again, here's z, okay, here's z, and I know that this side is the opposite side, but it's blank. I don't know what it is. Interesting. Okay. I know that this is going to be the hypotenuse here, and I know this is going to be the adjacent side. Okay. So in this triangle, I need to, right, if I'm going to do sine, and remember sine is opposite over hypotenuse, right? But if I don't have the opposite side, how am I supposed to do this problem? Okay. Well, if I know two sides of the triangle, right, so I know that this is 35 and that's 37, to find the missing side, wouldn't I do Pythagorean theorem? Yes, I would. Because don't I know that a squared plus b squared equals c squared? Okay. I know in my triangle, okay, that the a and b are the legs and c is the hypotenuse. Okay. Well, good. I have the hypotenuse labeled right there, so it's 37. And we'll just say A, adjacent, so we'll say that 35 is A, so we need to find B. All right, here we go. So 35 squared plus B squared equals 37 squared. Okay, so do you see how I plug that in? So the C is the hypotenuse. I knew what the hypotenuse was. Okay, then the legs, A or B, doesn't matter. So I put 35 as A, and B we didn't know. So we need to find out what B equals. Okay. So 35 squared, that's going to be a big number. It's going to be 1,225. Okay, so 1,225 plus b squared. And 37 squared is 1,369. Okay, so we have to get b squared by itself. So let's subtract 1,225. Okay. So that cancels out. I'm left with b squared equals 1,369 minus 1,325 is going to give me 44. Yep. Oh, 1,225, 144. So when I take the square root of both sides, I have b equals 12. Okay? So b equals 12, so that is my opposite side. It's 12. Okay? So that's part one, because if you didn't know the opposite side, how are you supposed to find sine of that angle? Okay? So sine of z equals 12. So now we can do opposite over hypotenuse. Okay? So back to the original problem, I have sine of z equals opposite, which we just found 12, over 37. Okay, and then we need to do 12 divided by 37, and I get, so sine of z, again all I'm doing is changing the fraction, is 0.3243. Okay, and of course using that fancy chart that you guys all received, again you would look at the sine column and look for 0.3243, and it's really close to 19 degrees. So I know that z is 19 degrees. So if you need to do a trigonometric function, but you're not given the right information, you have to make sure you find it, then do all the trigonometry stuff. Okay? So for number 18, we run into the same issue, right? So for number 18, okay? So for number 18, again, I'm modifying this, so let's pretend we don't know it's 50. Sorry. Okay? So let's pretend we don't know that side is 50. Okay? We know from angle Z that this is the opposite side because it's farthest away. This is the hypotenuse, which we don't know, but we really do. And we know that this is the adjacent side. Okay? So in order to do sine of Z, I have to know opposite over hypotenuse. But I don't know the hypotenuse yet. So I need to do trigonometry to find it out. Okay, so the hypotenuse, as we know, is always C. Okay, and the two legs could be A and B. It doesn't really matter. Okay, so let's go ahead and do trigonometry. So 30 squared plus 40 squared equals C squared, which is what we're going to find. Okay, 30 squared is 900. 40 squared is 1600. Okay, equals C squared. Which 900 plus 1600 is 2500. C squared. And if you take the square root of that, hopefully you know 2500 is a perfect square, which works out to be 50. Because 50 times 50 is 2,500. So the hypotenuse is 50, but again, we already knew that. All right. So it's 50. All right, so now we can do opposite over hypotenuse, which for this triangle would be 30 over 50. Okay. And again, if we're reducing fractions, which I always should be in the practice of, we can cross off some zeros, and then it's just 3 over 5. And hopefully, you don't need a calculator to know that 3 divided by 5 is 0.6. So I go to my fancy chart, and I go to 0.6 in the sine column, and it's really close to 37 degrees. Okay? So, I know that angle Z is 37 degrees. All right? Now, that's how you do it if you're given the trigonometric function in the triangle and you find the angle. But this time, look at number 19, 20, 21, and 22. Okay? So looking at these different things, I'm given the angle. It wants to know what the decimal is. Okay? I'm given the angle. I need to know what the decimal is. So it's as simple as going to your chart. Okay? So I go to the sine column, because look at number 19, so the sine column, okay? And I go to 48 degrees. And at 48 degrees, sine equals 0.7431. That's literally all they want you to do. Just go to the column and make sure you put the right number. I'll do number 21 here. So cosine of 61. So you go to the cosine column, and go down to 61, and it equals 0.4848. That's literally it. That's all you have to do. So I'll let you do numbers 20 and 22. Pause the video if you'd like to, if you don't want to see the answers immediately. Okay, and if I write down the answers, sine of 38 degrees is 0.6157. And cosine of 51 degrees is 0.6293. Okay? So it's literally as simple as that. And again, I hope this helps you and that you see you can actually calculate the trig ratios if you're given the angle, or given the ratios, you can find the angle.